Hello world and welcome to this edition of Tech on Fire with Blaze. I'm Blaze Stewart, an architect at Winelect, and today we're going to be looking at part 4 of our series on building a serverless blog on Azure. And today we're going to be looking at serverless functions in particular and how these things are coded up and how you can use these to build out APIs on Microsoft Azure. So today we're actually going to be looking at some code at what goes into making a serverless application. And up to this point, we really haven't talked about what serverless means. So today we're going to be looking at what a serverless application entails. Now, the actual application piece that we're going to be focusing on today is some code that would go into making something a serverless application. As the name implies, without a server, serverless really doesn't mean without a server. Actually, it's just running on somebody else's server that you don't manage. What serverless does mean is that you deploy your code or your application onto a server that you don't manage and a server that you don't actually pay for. What you do pay for is consumption-based metrics such as minutes of use of a given server or number of CPU cycles on that server. What you aren't paying for is capacity such as RAM and CPU and disk and network, those things that typically go into defining a virtual machine that define the capacity of a virtual machine that you would use as a server. In the serverless model, that paradigm is done away with. Rather, you just simply deploy your code and then it's metered on basically what you use on whatever box it's actually running on. And you really don't care a whole lot about what's under the hood. As long as your code gets executed and performs well, then they bill you based on simply what you use, not based on the capacity of the server, the RAM, CPU, and so on. Now, typically this is marketed as functions, such as Azure Functions on Azure. AWS Lambdas would be another example of this. Now, these functions are sold as functions as a service. Rather than deploying entire applications, you adopt whatever model that these particular clouds use, and then you write your code to those particular models. And this helps shape your code in a way so that the consumption is really geared at a request and response type model. It's event-driven programming rather than just having some kind of application that is always on running in the cloud. Now, a serverless function typically has 3 components to it. It has a trigger and then an output, and in between that it has code. So this serverless architecture really lends itself to event-driven programming. So the trigger in our instance that we're going to be looking at today is an HTTP trigger, but the trigger can be anything, like a timer could be a trigger, a message on a message bus could be a trigger, some kind of change in a file system can be a trigger. So you have a lot of options as to what can trigger the actual function to fire. And in between it and the output would be your code, and this can be JavaScript, it can be C#, F#, it can be Java, it can be Python, some even support PowerShell and Bash. And the code will receive whatever triggered the actual function to run. So there was some state that was necessary to produce this function to fire, and that state then gets injected into the code as usually as a parameter, and then the code will operate on that, and then there's going to have to be some kind of output, and that output can be something else entirely. So in HTTP, it's typically an HTTP response to an HTTP request, but that can also be writing a file, sending an email, putting something on a message bus. It can be any number of different kinds of outputs from a function. So when we look at the actual examples we'll look at, we're going to be looking at things that are triggers, outputs, and then there's going to be code in the middle to process that trigger and then write some kind of output, which in our case is going to be an HTTP trigger, JavaScript in the middle, and then an HTTP output. Going back to our serverless blog, this architecture outlines what the application is ultimately going to look like in terms of its components. Today we're going to be specifically looking at the Azure functions that are in the middle, and these are going to be forming up my APIs. So one common use case for writing serverless functions is to create application APIs that can be invoked by way of HTTP requests. And these APIs are primarily going to be interacting with data and content. So these three components are what I'm going to be looking at today in my demos. Now, I'm here in Visual Studio Code, and Visual Studio Code is my IDE of choice for doing this because it does have decent integration with Azure Functions and makes debugging and writing these things fairly easy to do. However, you can do it with Visual Studio 2017, 2019, or you can just do it with your favorite text editor like Notepad++ and the command line. All of those would work. It's based on NPM, so it's very easy to install with NPM. Just Google the instructions on how to do that, and it will take you to this page right here, and you simply just run an npm install, and it will install the Azure Functions core tools, and that will give you everything you need to start working with Azure Functions locally, including a local runtime that will allow you to actually debug these things locally before putting them on Azure. Now, going back down here to code, you can once you have the tools installed, it will give you this Azure icon where you can generate a new project, and it just walks you through a little wizard on where you want to put it and what you want to call it, and it'll provide some basic scaffolding for it. And once you have that done, you can click create a function, and then it will walk you through another little wizard for creating a function, and it will provide some scaffolding for your new function. So an application can have multiple functions as a part of it, which I have inside of this application. So currently I just have two functions that I have defined. I have one for pages and posts, which are different kinds of resources inside of my application. And when I created these, it created these three files here: functions.json and index.js and some sample.dat. And that's just a JSON file for sample data. And the functions.js, index.js, is just a hello world code, which I have since replaced with code that I actually am using. And then this functions.json file, which contains settings for the bindings for your application. Now, this particular application has different bindings associated with it, an input binding and an output binding. So my input binding is an HTTP trigger. As I mentioned, you can have other ones like timers, queues, and other types of things that would trigger this function. In this case, I'm using an HTTP trigger since I'm writing HTTP APIs. The direction is in, and the variable name is going to be request, and that's what's going to show up inside of my index.js, what's going to get injected in the actual parameters that get called inside of my index.js here. And these are the methods I'm supporting: get, put, post, and delete. So that means I'm supporting a full suite of CRUD operations, create, read, update, and delete on my given application here. And my output binding is simply an HTTP output binding. Its direction is out, and it's going to be response for the name of the actual variable that gets injected in my index.js. So with my input and my output binding set, I can now go into my code here and actually take a look at it, which in this case is a simple index.js that has a module export, which is very common in Node.js. Now, this would look very similar regardless of the language you choose. This happens to be how it's implemented using Node.js on top of Azure Functions. And notice here on my context, I have injected into my module here a function context and then my request. And then queued up on this request is a response object that I get to pass around as well. So this function is just really doing some routing based on some code, on the code based on the method that gets passed in. So my request has a method that's a HTTP get, put, post, or delete, and then it farms it out to another given function that is tied up in some common libraries I have defined up here in my data.js. I'm not going to go into the details of what this is doing in that level of details, but it is calling out to this data.js right here, and it's passing in that context, that request. I am going to go into this a little bit to look at one of these particular functions, just so you can have an idea of what it actually might look like. So you come into this, and I'm doing some table requests, getting some data. We've already looked at some table SDKs. So I'm actually using the Azure SDKs inside of these functions, like we've seen already, to do table queries and so on against my tables whenever we did look at some code last time in our videos. But this one is doing some data lookups, it's doing some scrubbing on it, and then it's building an array list right here, and then it's calling a method I called send response, which is actually on this, which is just a generic method that I have called send response. And what this is doing is getting that context object, and I'm just passing it along, and it's framing up a response. There's that res variable that is defined inside of my functions.json file. And I'm setting some kind of code that's a status code. HTTP status code could be 200, 400, or 500, depending on if there was an error or couldn't find something. The object for the body, which would be just some kind of JavaScript object. In this case, since this is a generic method, it's just going to post some kind of JSON object back. And then I'm setting the content type so that whatever receives this knows they're getting back some kind of JSON data. And once I've got all that set, I just call context.done, and then the actual runtime knows that I am done executing my code here, and then can go about sending that back to the actual client that actually called it, which could be a browser or something external to this application altogether. So with this kind of request and response and code in the middle, I can actually write out rather robust applications and APIs using functions on Azure. And this enables me to have APIs that can scale well. I don't have to maintain a bunch of servers or a bunch of IIS boxes. I don't really even have to get in the weeds on understanding exactly what goes on behind all this to actually make it scale. I just have to make sure that my code works well, and the details for a lot of those details that are needed to maintain the server are going to be managed by Microsoft. Now that I have this actually coded up, though, I can actually run this function, and I'm going to use Postman to actually call into it. So let's go ahead and start it up, and I can hit F5, and it's going to start executing my functions. Now, once my functions are running, I can come down here and look at the output, and notice it has my page API, so I can get put, post, and delete at this URL, and then the same here for posts. So that's what I can do on my Postman right here. So let me bring this over to my window that is being recorded, and here I have a actual demo already wired up. And sorry, this might be a little small on some screens. If I go Control Plus, I'll make it a little bigger, and I have here a get that is requesting something based on an ID. So the ID is getting passed into this API by way of a query, and if I run that, I hit send, it's going to actually call out to my table, do a query against that, and then pull back an object, and then it's going to read that object, get the actual blob name, and then pull back the content as well. And that's where I got this object from. So we've already looked at the structures that support this already, the actual table storage and the actual blob storage that undergirds this. But if I wanted to get just a list of posts, for instance, without that ID, I would just simply call this without an ID on it, and that would just send back 3 objects without the content, since that's going to take up a lot more time to load. And it's really not needed for this level of query. And the same with page. If I wanted to call the page API, I can do that very easily as well. And I can do a send on that, get the list of my pages. And if I want to get one in particular, I can do a query against maybe index, and then that will send me back the actual ID. If I got it's going to need a capital I, and give me back the content and the data associated with my page. So you can see how I'm just using this for get. If I wanted to use it for puts, the same thing would be true. A put would be to create a new one. I can also update an existing one with a post. So let's go ahead and do a post here on this URL. And if I come over here to my body, I have one here, but I can paste in this one, and I can do a post against this one and send it, and it will say the page and post was successfully saved, because I simply just did an update on it. I really didn't do anything other than just update the content with identical content to whatever it was there before. So these various APIs are what I'm going to be calling from my admin application whenever I actually start to build out the UI that is going to allow me to write a blog post or create a page and then ultimately publish this blog once this is finished. So this is going to wrap up our demo for today. In a future demo, I'm going to show you how to deploy these things to Azure and how we can use Azure integration with my application being hosted on Azure in a service in a storage account that's going to be calling out to an Azure function on Azure. Currently, we're just working locally, but right now, I just want to show you how these things are written and then what you can do to develop against a development environment such as Visual Studio Code. So until next time, thanks for watching this edition of Tech on Fire with Blaze. If you like this content, please consider visiting us online at www.wintellect.com, and there you can find about services that Wintellect offers, including training and consulting services. Also, please consider subscribing to this channel by clicking on the subscribe button and clicking the bell icon to get notifications when new content becomes available, and also comment down below. You can also follow me on Twitter at @TheOneMule, and also follow Wintellect on Twitter at WintellectNow or at Wintellect. We are constantly posting things about Azure-related technologies and things related to software development. You can also reach us by email at consulting@wintellect.com. Until next time, thank you.